Okay, today we are going to derive the distance formula, figure out where the distance formula comes from. So first of all, we want to think about what the distance formula is asking for. So we're going to go ahead and draw an xy plane. Okay. All right, so here's just your basic xy plane. What we're thinking about for this is we are trying to find the distance between 2 points on a plane. So let me go ahead and draw. Let's just pick 2 points. Let's say this is my first point. This is my second point. Oops. There we go. And we are trying to discover what the distance between those 2 points is. So I am going to draw that distance in red. That is our unknown. Okay. I'm going to call that D for distance. So that's what we're looking for. So let's go back and talk about what those points actually mean in the plane. Now we know that every point on a plane has an xy coordinate, right? So x comma y for each one. So these are 2 different points. So instead of labeling them both x comma y, we're going to label them x1, y1. Okay, where, oopsies, there we go. x1, y1. So 1 will stand for the first point, and then x2, y2. So that 2 will stand for the second point. So those are our 2 ordered pairs that we have. Again, we're going to try to find the distance. So what we're going to go ahead and do is draw a geometric shape that we know how to do with. If you look at this, this looks like just like a straight line. It is diagonal. Of course, not all of them are going to be diagonal, but this is a general shape. This is just some diagonal distance. If I take that diagonal distance and turn this into a triangle, I can force that to be a right triangle. Okay, what I've just created is a right triangle that we know is 90-degree angle, and we do know that for every right triangle there is a Pythagorean theorem that we can deal with. So let's go ahead and talk about that. That we know for a second, let me just draw off here to the side. We know that if you have any triangle, doesn't matter what it is, you can pick some labels A, B. If you were to let C be the hypotenuse, we do know that A squared plus B squared equals C squared. Okay, so this is the Pythagorean theorem. Okay, so that's something that we know. That's what we're going to use. Okay, D, as you'll notice over here, back to our question, D is our unknown. We're going to go ahead and try to find that unknown by using Pythagorean theorem. So I'm going to pick some labels for this. I'll just call this distance right here A, and this distance on the right hand side B, just for fun. Again, you could switch those, but that part doesn't matter. Now I'm trying to find that distance of A. So let's go ahead and look at our ordered pairs again, our points, x1, y1. Looking here at x1, y1, I could certainly draw a straight line down, possibly. There we go, a straight line down, and there is this point right there on the x-plane. So let's go ahead and look at that one more time. This is that point on the x-axis, and the same thing with the x2, y2. I can draw that straight down, and that is now the point on the x-axis. So if this was my x1 and x2, we know that that distance A, that the distance that A covers, is in fact starting at x1, ending at x2, ends at x2. Oh dear. That's not going to draw that for me. There we go. Ends at x2. So that distance would be x2 minus x1, right? Where you ended up minus where you started. That's that distance. Similarly for B, you will notice again if we do that with B in the y-axis, that's the up and down. This point right here would be the y1, and then this point over here would be the y2. So we know that that distance B covers y2 minus y1. Alright, now our picture is looking a little bit crowded. Let's redraw this without all the junk on the side so we can see just that triangle that we know how to deal with. So let's go ahead and redraw it. So we have our triangle, and I'll try to keep the colors the same there. The hypotenuse, we called it D. Right, and then we also had the sides of our triangle that we had originally called A and B, but let's go ahead and call them what they are. They are, in fact, this was the x2 minus x1. This was y2 minus y1. I'm going to go ahead and put those in parentheses. That part doesn't really matter too much. Whoopsie daisies. But you can. Alright, so that's that. So that's what we've got as our picture. Again, we're going to go ahead and use the Pythagorean Theorem. The a squared plus b squared equals c squared. But what we will now have is that the x2 minus x1 will be my a. y2 minus y1 will be my b. And then the hypotenuse, that distance that we're actually looking for, will be my c. Alright, so that's what we've got. So let's go ahead and set up that formula that we've got. So this is now going to be a squared, which was x2 minus x1 squared, plus b squared, which was y2 minus y1 squared, equals c squared, which in our case we called that distance d. So this will be d squared. And then if you remember, we are trying to find the distance, so we are in fact looking for d. So we can go ahead and take the square root of both sides to isolate that d. So when you take the square root of both sides, that will be nice. You don't have to worry about the plus or minus in this case, because we're looking for a distance, and distance is always positive, so you can just keep that positive. So distance equals, and I'm left over with the square root of x2 minus x1 squared plus y2 minus y1 squared, which is in fact the distance formula. So this is how you find the distance between any 2 points. A lot of times you'll see it written as distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We have just proved the distance formula. Ta-da!